Now we want to solve another problem, another linear programming model in finance, which is portfolio optimization, page 72. In this example, we are dealing with the six investment option. Each of the investment options has rate of return. They are ranging between 8.65 to 10%, and the years that they are get mature varies between 6 to 13 years, and they have the rating. So we are trying to invest the available fund, which is $750,000. So the set of the constraint is that in none of the investment option we cannot invest more than 25%. At least half of the money should be invested on the long-term bonds that mature in the 10 years or more. And then we cannot invest more than 35 on the three of the assets, which are Dynastar, Eagle Vision, and OptiPro. The objective function is obviously we want to have a higher return. First of all, we have to define the decision variables. So here we have six alternatives, six decisions that we can make. So we can define x1 to x6, which is the percent of the money that we invest, or the amount of money we invest in each of these companies, each of these assets. So x1 is the amount of money we invest on Acme Chemical. X2 is the amount of money we invest on Dynastar, and so on. So this is my decision variables. And when my objective function is we want to maximize our return based on investment. So my objective function is multiplying this value times x1, which is the money I have invested on this one, on this asset, plus this percentage multiplies by the amount of money I invested in this company, and so on. So the objective function is multiplication of each of this percentage that we get from the investment and add them up. So this is the objective function we get, and the type of the objective function is maximization. And then we have three set of the constraint. First of all, we have to invest all the monies. So that means the summation of the money I invest on each of these companies should add up the total money I have right now, which is 750,000. So x1, the summation of x1 through x6 should be equal to total amount of money. And then I cannot invest more than 25% on any company or any asset. So each of the xi should be less than 50,000 times 20% of the money. So the amount I can invest on each asset should be less than this value for all of the assets I have. And then I have to invest at least 50% of the money on the long-term bonds. Here the long term is defined more than 10 or more than 10 years. So we have this one, which is x1, so, and Dynastar, and micro modeling, and Saber systems. So x1, x2, x4, and x6 are the long-term investments. So the summation of x1 plus x2 plus x4 plus x6 should be more than 50%. So as we shown this in this example. And then we cannot invest more than 35% on x2 on the Dynastar, Eagle Vision, and OptiPro. So x2, x3, and x5. So the summation of x2, x3, and x5 should be less than 35% of the investment. And then we can put this model in Excel and solve it. In this table, we modeled this problem. This is the decision variables and the values that we have invested in each of the assets. So total is 0. And then the maximum that we can invest in each asset is 25%. So if we multiply this value, which is a maximum available of the fund is going to be this value, and you can see multiplied by this value. So each of these investment options should be less than these values. And also the assets that they are considered long-term are presented in this column. So if we multiply these values by these investment options, it should be less than the half of the investment. So this is another constraint we have. And then based on the preference of the investor that he or she is interested in investing in these options, we have this kind of parameters. So once we have implemented this on the Excel, we can solve this model. So the objective function is this cell, and the type of the objective function is the maximization, and then these are the decision variables. And then the constraints we have is that this should be less than or equal of this value, and then this should be less than this value, and all of the investment should be exactly same as the total amount of the money we have. So this is a model, and then we put this one is variables are positive or 0 or positive, and then the type of the solution is a simplex linear programming, and then the money we invest in on each asset should be less than 25 of the assets. So I just added. So let's run the model again, and then you see this is a solution for the exam. So you can see that whenever we solve the model, the total investment is exactly same as the money we have, and this value shows the investment that we have done on each of the assets, and you can see it satisfies all this constraint, even though we are exactly on the boundary for these 3 assets, but the rest of them are less. And then also we are investing on this much money on the long-term assets, which is at least should be this much, and we are exactly investing this amount on the good values, which is satisfy the requirement.